Hello, boys and girls. Here we go. Chapter 3, Lesson 5, Multiply with Regrouping. This is another one of these lessons that your parents are like, hooray! We do this! We did this when I was in school! Zippity-doo-dah! This is what we call the multiplication algorithm. And it's not the only way to multiply, but it's the most efficient. Okay, it's the way that you'll multiply these kinds of numbers eventually all the time, because efficient means correct but quick. Okay, doesn't mean that you have to go fast when you do it. It just means that you get it done correctly with the fewest number of steps. Okay, so you multiply every number by every other number, so everybody gets a turn. We start with the ones place in the bottom number. So 8 times 3. 8 times 3. Those are both in the ones, right? So that's just plain old 8 times 3. So 8 times 2 is 16. 8 times 3 is 24. So we're going to regroup. And remember that the 4 goes there because in the number 24, which one of those is in the ones place? The 4. So the 4 is the one that goes down there in the ones place. And the 2 has to be added on to the tens because it's 2 sets of 10. Okay, we're not done with you 8 yet. We're going to go over here now and go 8 times 7. Because like I said, everybody gets a turn. 8 gets its turn times 3. 8 gets its turn times 7. Okay, so 8 times 7. 8 times 7, oh golly. Oh wait, that's the hard one. 5, 6, 7, 8. 5, 6, 7, 8. That's right. It's 56 plus the 2 sets of 10 we already had there. 56, 57, 58. Okay? So, is there anywhere else to like regroup right there? No. That's a 2-digit number. So we put 58 right here. Okay? So guys, be careful when you record these numbers that your place values look nice and lined up as you do your next one, okay? I'm going to change colors here. Now, we are done with the ones place. We are done with you 8, right? Did we use this 2 up here? Yep, bye-bye. We're done with you also. Another way we show that we're done with the ones place is we put a 0 in the ones place, because now we're moving over here to the 2. And that's just not 2 ones, that's 2 sets of 10. So that 0 goes there to show everybody, hey, we're done with the ones place. No more ones times ones. All right, so here we go. 2 times and go to the 3. Now we are multiplying the 3, which is in the ones place, but it's by 20. But we call it 2 tens. So 2 tens times 3, 2 times 3 is 6. That 6 goes right there. Okay? Because like I said, it's really 20 times 3, and you know 20 times 3 is 60. So does that make sense to you? Yeah. And then everybody gets a turn. The 2 now is multiplied by the 7. 2 times 7, as we know, is 14. Is there anything there that we need to use to regroup? No, there's no more place values over there. So we're going to put 14. We're just going to write 14. Okay, so we're going to review. 8 times 3 is 24. 8 times 7 is 56, plus those 2 is 58. Done with the ones. Put a 0 in the ones place and say farewell to the 2 that you regrouped, because we already dealt with that. We're moving to the tens. 2 times 3 is 6. 2 times 7 is 14. And so now we have 2 partial products. So you see how that's a little more efficient? All right, so we add them up. 4 plus 0 is 4. 8 plus 6. Okay, 14. Oh, and look at this. 1 plus 4 is 5, so that gives us a nice 5 plus 5 is 10. Okay, so your final product is 2,044. So you just did multiplying with regrouping. Now, Mrs. Olvey forgot to estimate first. So let's do that zippity-doo-dah right over here. We can barely read it now. It said 73 times 28. 73 rounds to 70. 28 rounds to 30. Just multiply those two. 7 times 3 is 21. 2 zeros. Whoop. There's our estimate. Sorry about that. Okay. Let's see. Is that a reasonable product? 2,044? Yeah, those are very close. Okay. Estimate and actual product. All right, let's do this one, number 3. And this time I'll do the estimate first. 48 rounds to 50, and 38 rounds to 40. So let's see. 4 times 5 is 20, and then 0, 0, 0, 0. So our estimate is 2,000. All right, so let's get started with the ones place. 8 times 8 is 64. I'm just going to help you along there. 64. Right? Now don't forget, 64, that 4 is in the ones place, so it makes sense that the 4 stays in the ones place. Now we're going to go 8 times 4. 8 times 4, 8 times 2 is 16, double 16, it's 32. 32 plus 6. Now, if you can't do 32 plus 6 mentally, whoops, write it down. Hang on a second. That's too hard to read. 32. You can write it down over to the side. It's 38. Or you can just go 32, 33, 34, 35, 36, 37, 38, 38. Okay? 38. 4 times 8 is 32, plus 6 is 38. Okay? So we show everybody we're done with you ones place by putting a 0 in the ones place, and then farewell to you plus 6. We already used you. We don't need you anymore. Okay, so moving along, let's go over to the tens place. So remember, everybody gets a turn. 3 times 8. 3 times 8, let me see, 2 times 8 is 16. One more set of 8, right? Okay, so that's 24. So in this case, we have a little regrouping here, right? 3 times 8 is 24. So I'm going to put the 2 up here and the 4 down there, because we can't, of course, we can't just shove the 24 down there into one place value, but we need to add those 2 sets of 10 onto our next step when we multiply 3 tens times 4 tens. Okay, 3 tens times 4, 3 times 4 is 12, plus those 2 sets of 10 from 3 times 8. So 3 times 4 is 12. 12 plus 2 is 14. 14. Okay? And remember, you have to line these place values up nice and tidy, because after all that hard multiplying, you don't want to make a mistake adding, right? So let's see, 4 plus 0 is 4. 8 plus 4 is 12. I'm going to regroup. 4 plus 3. Oh, look, 3 plus 1 is 4. 4 plus 4, 8, and a 1. All right, so our actual answer is 1,824. And let's see, our estimate was 2,000. Yeah, I'd say that is a reasonable product according to our estimate. Okay? All right, let's practice a couple more of these guys. Now this one's at the bottom. Baseballs come in cartons of 84 baseballs. A team orders 18 cartons of baseballs. How many baseballs does the team order? So they got some cartons. Baseballs come in cartons of 84. So in every carton are 84 baseballs, and they ordered 18 of them. So they ordered 18 cartons of 84. 18, hang on a second, that's too high. Okay, 18 cartons of 84 baseballs. Are you with me? Okay, so let's practice the multiplication algorithm, or multiplying with place value, or whatever they call it, right? Here we go. 4 times 8. Gosh, this one's come up a lot. 4 times 8. 2 times 8 is 16. 4 times 8 is double 16, or 32. Okay, 4 times 1 is 4, plus 3. 4, 5, 6, 7. So 7. Okay, I can move on now. Let's see. I'm finished with the ones place. I show that by putting that placeholder in the ones place. I'm finished with you up there because I already added you on. And I move to the tens place now. Okay, so here we go. 8 times 8, so it's the tens times the ones here. 8 times 8 is 64. Now we've talked a lot about strategies for your 8s, so I hope you use good ones when you do this, okay? 8 times 8 is 64. 8 times 1 is 8. And what do we still have to do here? Did you remember that? We have those 6 tens from 64 that we have to add on. 8 times 1 is 8 tens plus 6 more. 8, 9, 10, 11, 12, 13, 14. Goodness, this sticks way out here, doesn't it? Okay, place values lined up. 2 plus 0 is 2. 7 plus 4, 7, 8, 9, 10, 11. 4 plus 1 is 5. And then 1 plus nothing, right? So the baseball team ordered 1,512 baseballs. Good gravy. How many baseballs does one team need? 1,512 baseballs. Sheesh. All right, here we go. Okay, we are on the lesson check on the back. Reading with me. This one's a little teeny, isn't it? The art teacher has 48 boxes of crayons. There are 64 crayons in each box. Which is the best estimate of the number of crayons the art teacher has? Did you hear a special word in that problem? Let's go back and reread it. The art teacher has 48 boxes of crayons. There are 64 in each box. Which is the best estimate of the best estimate of the number of crayons? I thought we were going to have to do another big multiplication problem, but we just need an estimate. Okay, so 48 boxes of 64. Let's use rounding as a way to get our estimate. Okay, 48 rounds to 50. 64 is closer to 60 on the number line. Okay? Now don't forget, guys, when you have these zeros, you can just do the basic fact. You don't have to be like 0, 0, 0, 0, 0, 0. Just do the basic fact. 6 times 5 is 30. 0, 0, 0, 0. Okay? So the art teacher has about 3,000 crayons. Goodness gracious. Maybe he's going to work with the baseball team with their 1,500 baseballs with his 3,000 crayons. All right. So this one is down in review. Okay? And it's the lesson that you just finished, really. Lesson 4 in chapter 3. Okay? All right, let's start reading it. Here we go. One Saturday, an orchard sold 83 bags of apples. There are 27 apples in each bag. Which expression represents the total number of apples sold? Well, look at these, the way they're written. I see 4 parts, right? So do you think that the product is broken down into partial products? Perhaps. Let's find out here. So 27, 83. Do you see where I got those, boys and girls? 27 apples in each bag, 83 bags. So there are 83 bags of 27 apples. Okay, 83 groups of 27 apples. All right, so let's see here. 20 times 80, oh, well, 2 times 8 is 16, and 2 zeros. Now I'm looking at the answers. Oh, there's 1,000, but don't choose that one yet. Let's see how we do here. Here we have 7 rows of, where do we find that one? That's right, look for that parallel line that's the same length. 7 rows of 80. 7 times 8. 5, 6, 7, 8. 5, 6, 7, 8. 56. Ching. 560. Oh, there it is. Okay. It's right there too, but I don't see the 1,600. All right, let's keep going. We'll do this one. This is 20 rows of 3. Oh, that's a little mental math there, right? 2 times 3 is 6. 60. Oh, I think we have a winner. Let's double check, though. Don't jump to conclusions, okay? Ding, 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 ding. Our little ones place box, right? 7 is here. So 7 is here. 7 groups of that line is equal in length and parallel to that line. 21. Ding dong D. You are the winner. Those are the 4 partial products of 83 times 27. All right, one more in the review department. We're going back to chapter 2, lesson 2. Phil has 3 times as many rocks as Peter. Together, they have 48 rocks. How many more rocks does Phil have than Peter? Okay. Can I just multiply 48 times 3? Does it say that Peter has 48 rocks and Phil has 3 times that? No. It says together they have 48 rocks. So this is one of these guys. There's Phil and there's Pete. All right. Why couldn't they have thought of 2 people with different names or different letters that started their names, right? Let me see here. I always like to see who has more. Right up here, Phil has 3 times as many as Peter. So Phil has 3 times as many as Peter. And then together, they have 48. Okay, so these boxes represent equal sets of an unknown number right now, right? All right, so we know that all of those boxes together make 48. So 48 equals 1, 2, 3, 4. 4 equals sets of n. 4 equal sets of n. So 4 times something is going to get us 48. Well, I'm going to look up here at my choices. All right, 4 times 36. No way, because I know that 4 times 30, 4 times 3 is 12. 4 times 30 is 120. That's way too much. No, sir. All right, let's look at 24. 4 times 24. Well, I'm going to do the same thing I just did. I know that 4 times just 20 is 80. So we only need 48. No, goodbye. You're too big too. All right, so we are left with 16 and 12. Do you want to, oh, I think I have an idea. Do you see that 2 in the ones place there? Let's try putting 12 in for n. And you know why I chose 12? That 2 in the ones place, when I multiply it by 4 ones, guess what I'm going to end up with in the ones place? Let's do it right here. 12 times 4. We're trying to get 48. 4 times 2 is 8. 4 times 1 is 4. Aha! Okay? So n in this problem equals 12. Oh, you know what? That wasn't even the question they were asking. Oh my goodness. But you know, all right, so goodbye, goodbye. You know what? I just lucked out. But you know what, boys and girls? I'm glad I made this mistake because it shows you that even adults just jump right to the answer, which is exactly what I just did. Okay, I was looking at these choices, trying to find the right choice for the value of n, and that's not even what they were asking. Oh my gosh. Let me go back here. How many more rocks does Phil have than Peter? They didn't want to know what the value of n was in the question. But now that we do know that, we can do 12, 12, 12, 12. Okay? So let's see. How many more rocks? Sometimes I like to do this, like when I was just first learning to subtract. They both have 12 rocks, and this is how many more Phil has. So Phil has 12 and 12 more, 2 sets of 12 more. Ring-a-ding-ding. Phil has 24 more rocks. Now, if you don't want to do it like that, you could say, okay, Phil has 3 sets of 12, which is 36. 36 minus the 12 that Peter has. 6 minus 2 is 4. 3 minus 1 is 2. 24. Okay? Whew! Wiping the sweat off my brow on that one. I almost made a mistake, but I saved myself. All right, guys, do the rest of them and have a great night.